Imagine for a moment that you're standing on the silent, endless plains of the lunar surface. The Earth glows above you, a radiant blue marble in the black sky. Beside you, not just an astronaut, but a sleek, all-terrain vehicle that looks like it rolled straight out of a sci-fi blockbuster. This isn't some far-off fantasy. It's the frontier of a new space race, one that's not simply about planting flags, but about laying foundations for an entire economy beyond Earth. So here's the big question. Can a new generation of lunar rovers really unlock the moon for humanity, transforming it from a barren rock into the next big hub of science and business? The stakes are enormous, the challenge is even bigger. The latest lunar rover designs don't just aim to drive across the moon, they promise to build the backbone for future bases, research labs, and even businesses operating 238,000 miles from home. But will they succeed? Or will the moon's ancient perils, brutal cold, deep shadows, lethal radiation, halt our ambitions yet again? Let's dive into a crash course on why the humble lunar rover could be the most important vehicle of the 21st century, and what's at risk if we get it wrong. 50 years ago, the world watched as astronauts bounced across the moon in dune buggy-like vehicles during the Apollo missions. Those early lunar rovers, officially named Lunar Roving Vehicles or LRVs, were marvels of their time. They extended astronauts' reach, allowing for longer excursions and more samples collected. Before the LRV, the moonwalkers could barely stray a mile from their landing sites. With it, they reached up to 22 miles in total travel, unlocking a radically larger footprint for human exploration. But those first rovers had serious limitations. They were lightweight, open-air contraptions. Think of a glorified golf cart rather than a Mars rover. The batteries only lasted a few hours. Without adequate shielding, astronauts were exposed to radiation and temperature swings that could end missions, or lives, in minutes if anything went wrong. And once the mission ended, the rover was abandoned forever, left to gather moon dust in silence. The decades since Apollo have seen astonishing advances in robotics, automation, material science, and communications. Yet, despite all our technological progress, humans haven't set foot on the moon since 1972. That's about to change, big time. The Artemis program, led by NASA but with international and commercial partners, aims to return astronauts to the lunar surface as early as 2026. But this time, the ambition is far higher, to establish a sustained human presence, not just short visits. The lunar rover is no longer just transportation. It's the essential workhorse, supply chain, and even emergency shelter rolled into one. Today's lunar rovers bear almost no resemblance to their Apollo-era ancestors. For Artemis, NASA is rolling out the Lunar Terrain Vehicle, or LTV, with a minimum range of 12 miles, even more if extra battery packs are added. Imagine the difference. Instead of hugging the landing site, astronauts could traverse vast new regions, reaching into deep craters and up soaring ridges. And it's not just the Americans. Japan's JAXA and automaker Toyota are collaborating on the Lunar Cruiser, an enclosed, pressurized rover with ambitions so bold it spans 10,000 kilometers in cruising range over the rover's lifetime. That's enough to drive from New York to Los Angeles and back, on the moon. It even has a closed-loop life support system, recycling air and water and allowing astronauts to survive for weeks at a time, vastly extending mission possibilities. Europe wants a piece of the action too. The European Large Logistics Lander, or EL-3, is in development to deliver not only rovers, but an incredible 1.7 tons of scientific equipment and supplies to the moon's surface. Imagine the logistical leap that represents permanent bases, regular supply runs, and an infrastructure that echoes the early days of transcontinental railroads, but on another world. There are major private players as well. Astrobotic, a pioneering U.S. company, is building the Flex rover with NASA's Viper mission in mind. What's so special about Flex? It can roll into the moon's permanently shadowed regions, the mysterious zones at the lunar South Pole that never see sunlight and might hold vast reserves of water ice. As John Thornton, Astrobotic's CEO, puts it, Flex's mobility and payload capacity will revolutionize lunar science, allowing us to explore previously inaccessible regions and conduct more comprehensive research. But surviving in those polar shadows isn't just about rugged tires or big batteries. The moon's night is brutal. Temperatures can plunge below -240 degrees Fahrenheit and stay there for weeks. Electronics and batteries freeze. Steel turns brittle. To address this, the latest rovers use cutting-edge technologies like the heat switch device from Nagoya University and JAXA. This gadget cleverly manages lunar temperature extremes, slashing power needs for heating by up to 100% compared to old-school heaters. Dr. Masahito Nishikawara, who helped develop the tech, says, "Our heat switch technology is crucial for enabling long-term lunar missions by efficiently managing temperature extremes with minimal energy use." Mobility isn't just about wheels. Rovers like Flex feature advanced suspension systems that let them climb slopes up to 30 degrees, even while hauling nearly 3,300 pounds of gear or samples. Imagine the loads we could haul: scientific instruments, habitat modules, or even mining equipment for extracting lunar resources like water ice, which could be split for rocket fuel or drinking water. Power is another game changer. Some rovers, such as the Lunar Outpost's MAP, don't rely on solar panels alone. Instead, they use wireless power transfer, a kind of remote charging beam sent from a base station, which lets them operate for weeks without ever stopping to recharge in the harsh lunar night. That's a logistical dream come true for a construction crew or a mining team on the moon. Meanwhile, protection against cosmic hazards is top priority. Apollo astronauts were fortunate to dodge major solar flares, but luck is not a strategy for the future. The Artemis LTV and other next-gen rovers use advanced radiation shielding to reduce exposure by up to 50% compared to older models. That could make the difference between safe exploration and disaster. All these innovations are converging on a singular goal: making the moon not just a place to visit, but a place to live and work. The new lunar rover is not merely a vehicle, it's a linchpin technology for humanity's sustained presence in deep space. And the potential payoffs are immense. If we can master these machines, we could see permanent lunar bases supported by fleets of autonomous rovers, conducting non-stop surveys, extracting resources, building habitats, and ferrying supplies between sites. Picture an armada of robots, working day and night, silently reshaping the lunar surface into the first true off-world economy. But here's where the real tension kicks in. Every advantage comes with an equal share of risk. First, the moon's environment is more dangerous than almost anywhere on Earth, and still barely understood. Lunar dust isn't just inconvenient, it's razor sharp, sticks to everything, and can destroy electronics, seals, and machinery over time. During Apollo, dust damaged spacesuits and gummed up mechanical joints. Multiply that by months or years, and the problem becomes potentially catastrophic for our future machines, and anyone depending on them. Next, let's talk about autonomy. The vision of swarms of rovers, mapping, mining, and constructing, demands artificial intelligence that can make rapid, high-stakes decisions with minimal human input. Communications with Earth are limited by the speed of light. There's up to a 2.6-second delay each way. That means rovers must recognize and solve problems instantly, without waiting for instructions. A single software bug or unexpected hazard could cause millions in lost equipment, or worse, endanger crew lives. Then there's the question of logistics. Even with ESA's new lander and increased payload capacity, lunar supply chains are fragile and incredibly expensive. Every kilogram sent to the moon costs tens of thousands of dollars. Failure of a single rover or vital part could jeopardize years of planning and hundreds of millions of investment. The moon offers no backup. Repair crews aren't just a truck ride away. And perhaps the most chilling problem of all, radiation. Solar particle events and cosmic rays could cripple electronics in seconds. Even with improved shielding, is it enough? Apollo astronauts spent just a few days on the moon. Future crews might be there for weeks or months, exposed to unpredictable cosmic weather. Let's not forget the economics. Building, launching, and operating lunar rovers is a high-stakes gamble. A handful of successful missions could open trillion-dollar industries, mining water ice, processing lunar regolith for construction, even building solar power plants. But every failure feeds critics who claim lunar development is an expensive boondoggle, doomed to repeat history's cycle of hype and disappointment. Investors are watching and waiting for proof that these new rovers can deliver on their promise. Finally, there's the ethical and legal gray zone. Who owns what on the moon? If companies or nations claim rights to lunar resources, could this trigger international tensions or even conflicts? The 1967 Outer Space Treaty was written when lunar mining was science fiction. Now everyone from NASA to private firms is eyeing the same ice-rich craters. Whose rules will apply when the first rover starts digging? Despite the optimism, these questions cut to the heart of our moonshot ambitions. Will the next generation of lunar rovers usher in a new era of opportunity? Or will they reveal just how hard, dangerous, and costly it really is to build the first space economy? As we stand at the edge of another giant leap, the world is watching. The new lunar rover is rolling out, not just onto alien soil, but into a tangle of technical, economic, and geopolitical challenges. So, can we conquer the moon's most unforgiving environments and build a sustainable, profitable presence beyond Earth? Or will the dream and billions in investment vanish in a cloud of moon dust? The answer may rest on what happens in the next few critical years, as the first of these advanced machines begins its historic journey across the lunar frontier. But there's an even bigger question brewing. What happens if, or when, something goes wrong? But what happens next? As these new lunar rovers inch closer to their first critical trials on the moon, the outcome is far from certain. In these high-stakes moments, the success or failure of these advanced machines could shape not just the future of lunar missions, but the very way humanity approaches exploration beyond Earth. The next decade will be a proving ground. Imagine it, a convoy of sleek autonomous vehicles gliding over the moon's powdery regolith, braving freezing nights, deadly radiation, and brutal slopes to deliver science, supplies, and even construction materials. At the lunar South Pole, rovers like Astrobotic's Flex and JAXA's lunar cruiser will attempt dangerous descents into pitch-black craters, searching for ancient water ice, the single most valuable resource for future explorers. The stakes are huge. If these rovers can survive, adapt, and perform, they'll lay the foundation for humanity's first permanent off-world outpost. If they falter, we could lose years or even decades of progress. But let's consider the possibilities if they succeed. One scenario: fleets of different rovers, each designed for a unique mission, work in perfect sync. Cadre's team of autonomous scouts collaborates to map out safe routes, while Flex's massive payload ferries heavy scientific gear and building blocks. The lunar cruiser, equipped with a closed life support system, becomes a vital mobile base, allowing astronauts to explore further and longer than ever before with minimal resupply from Earth. Picture this. One day, you wake up to headlines of a fully operational lunar base, made possible by a robotic workforce that never sleeps. Going further, private companies might deploy their own commercial rover fleets, offering delivery service for minerals, scientific samples, or even lunar tourism equipment. Amazon Moon Prime, anyone? The concept sounds far-fetched, but the seeds are being planted right now. The business side is as cutthroat as ever. Companies like Astrobotic, Lunar Outpost, and an entire ecosystem of agile startups compete for contracts from NASA, ESA, JAXA, and private investors. Some will thrive, others will collapse, and the winners will set the standards for lunar logistics, infrastructure, and maybe even the rules of lunar commerce. However, the risks remain as real as the opportunities. The moon is not a forgiving environment. Temperatures swing from boiling to hundreds of degrees below freezing. Razor-sharp dust particles infiltrate even the best mechanical seals. Solar storms bombard metal and electronics with deadly radiation. As John Thornton, CEO of Astrobotic, bluntly puts it, the moon will break anything you're not 100% sure about. Even the most advanced tech can fail. Consider lunar night, an unforgiving stretch of darkness lasting up to 14 days. Without innovative thermal solutions, like Dr. Masahito Nishikawara's EHD heat switch, even the hardiest rovers may freeze dead until sunrise. But if these inventions work in practice, as initial tests suggest, lunar vehicles could operate year-round, opening 24/7 access to all corners of the moon. And then there's the geopolitical angle. If a few nations or corporations dominate lunar access, could this spark new forms of space race rivalries? The need for international collaboration, as ESA's Dr. Yuland Wang emphasizes, has never been greater. The shared infrastructure, like ESA's giant EL-3 lander for cargo and rovers, could turn the moon into a laboratory of global cooperation, not just competition. But what about you watching from Earth? Beyond the stunning visuals and high drama, what practical benefits and lessons can ordinary people draw from this new era of lunar rovers? First, it's a masterclass in problem-solving under extreme conditions. Every breakthrough, from wireless power transfer to closed life support, addresses a challenge more daunting than any faced on Earth. These solutions ripple into our daily lives. For example, battery improvements and automatic systems designed for lunar night are already influencing consumer electronics and electric vehicles. Second, lunar exploration is a catalyst for international collaboration and STEM inspiration. As Bill Nelson, NASA's administrator, points out, the Artemis program and its lunar rovers will not only expand our scientific knowledge, but also inspire a new generation of explorers and innovators. This applies whether you're a student considering a career in engineering, a teacher looking for inspiring lessons, or a business leader seeking new technology trends. The moon is a giant laboratory for the innovations of tomorrow: autonomous machines, extreme robotics, regenerative life support, modular batteries, and smart shielding. As these technologies mature through the ultimate test in space, they'll trickle back to Earth, transforming industries from healthcare to clean energy. There's a lesson in adaptability, too. These rover missions are built on iteration. Try, fail, learn, try again, until the solution works. It's the kind of resilience every entrepreneur and innovator should embrace. The pace and scale of lunar competition force teams to think creatively, take risks, and collaborate across borders, cultures, and disciplines. These are lessons every ambitious viewer can use. And then there's the bigger picture. For some, lunar rovers are about science, finally unlocking the secrets of the moon's origins, or searching for clues to how water and life itself arrived in our solar system. For others, it's about business, the prospect of mining rare resources, generating new wealth, and building the next frontier economy. But for humanity as a whole, it's about proving that we are not limited to one planet, that with creativity, perseverance, and global teamwork, we can thrive even on the harshest frontiers. So where does this leave us? Can the new generation of lunar rovers, and the people and companies behind them, truly overcome the relentless technical, economic, and geopolitical challenges standing in the way of a new lunar era? The honest answer? It won't be easy. There will be failures, setbacks, and fierce competition. Some rovers won't survive their first lunar night. Some companies will fold, and some governments may clash. But with each small step, we learn. The progress doesn't happen in giant leaps. It's a dance of innovation and persistence. As Dr. Clive Neal of the University of Notre Dame puts it, access to permanently shadowed regions is essential for understanding the moon's volatile history and identifying potential resources for future lunar bases. If these new machines can master those shadowed, dangerous environments, the door to a permanent human presence on the moon will swing open. If they succeed, the upside is world-changing. Imagine lunar water fueling rockets to Mars and beyond. Imagine scientists remotely exploring alien terrain with robotic avatars in real time. Imagine school children everywhere watching a 360-degree live stream as the next rover builds the first foundation of a lunar village. And here's a secret fact many overlook. These lunar breakthroughs could mark the dawn of an entirely new era, not just for the moon, but for how humanity approaches life on Earth. The technology born of lunar hardship will shape our future here at home. Closed-loop life support? It could revolutionize water saving in drought-stricken regions. Advanced autonomous vehicles? They could transform disaster relief and farming. Extreme thermal management? Picture affordable, ultra-efficient insulation in homes and battery packs worldwide. Ultimately, the story of the new lunar rovers isn't just a tale of machines scurrying across distant gray plains. It's a test of our imagination, our ability to solve problems as a species, and our willingness to collaborate on challenges that matter to all of us. So, the next time you see headlines about another lunar rover launch, look closer. Behind every wheel, every battery, and every line of code, there's a worldwide effort to push boundaries, defy limits, and create something extraordinary, on the moon and right here at home. Are you ready to follow the journey? Subscribe if you want to stay on the cutting edge of space exploration, tech breakthroughs, and the new lunar age. Drop your thoughts in the comments. What would you build on the moon if you had a fleet of rovers at your command?